Alright guys, it's Chili back at you with another lesson. This is lesson 14 of the beginner series, for those of you who cannot read Roman numerals. We're gonna get on the topic of this lesson, which is basically I'm gonna show you guys the solution for lesson 13. It's gonna take a while. I know it's going to take a while because I've actually already recorded it, and now I am re-recording the intro because I fucked something up. So yay, you get some behind the scenes info there. But before I show you guys how to solve lesson 13, I want to share something with you. So every now and then, a member of the board will post one of their creations, and I just want to share a couple of them that we've gotten in the last week or so. So the first one here is it's a Minesweeper clone made by a board member who goes by the username DeLoten. He's from Germany, and he's had some programming experience in the past. Oh, and I got fucked right in the beginning. How do you like them apples? Let's try that again. I will not be denied so easily. Okay. Let's see here. There we go. Now we've got some action here. So that means we can get this one, and this one goes like that. So this is a pretty good clone, considering that you can't use the mouse, because I haven't shown that yet. One thing I like about this is in normal Minesweeper, it shows you how many mines are surrounding a particular square by writing a number in that square. But because we can't use numbers, that's not right. Because we can't draw numbers that easily. DeLoten has replaced numbers with just dots, like, you know, on dice. And I think that's a really smart idea. You might not be that impressed, but I know a lot of people who would be like, well, I want to make Minesweeper, but I can't draw numbers, so it's going to be too hard. No, fuck that shit, man. Find a way around it. Think of a workaround. That's what a lot of programming is about, working around shit. So I know a lot of you guys are complaining about, you want me to show you how to do sprites and shit. I am going to show you how to do sprites. Calm the fuck down. But that is no excuse to be, not making games already. You can make tons of games just using basic line drawing algorithms and circle drawing algorithms here. Vector art is what I'm saying, and very simple compiled sprites where you do put pixel. You can make a shit ton of different kind of games doing that, and you should be doing that. You should be getting that experience. It's very easy to just say, oh well, I can't do A, B, and C, therefore I can't do anything. Fuck that, man. Get out there, crack open that compiler, and make those fucking programs. Okay. Now another user who goes by the name xekis on the forums, he made a program here, and this program is pretty awesome too. The only problem is he made it in like a gigantic resolution, so it doesn't all fit in my my recording screen here, unless I resize it. And if I resize it, then it I don't know, it looks stupid. Hard to explain. But yeah, so this is it. And it uses some very simple physics here. Whoa! Acceleration and gravity and whatnot. And you gotta control this spaceship and basically pick up these green faces while avoiding the red ones. That's how it works. And it's pretty cool. He uses, it's all vector art. There are no I don't think there are any compiled sprites in this one. And if you notice, the ship gets bigger and bigger as you collect shit. So he actually scales the size of the ship, and you can do that with line art, no problem. It doesn't look good if you do it with pixel art. It gets all pixelated, right? So he's making good use of the vector art algorithms here. Oh, something just went crazy. Well, it looks like I managed to find a bug in his program, but no, it's quite impressive. I like the art design of these faces here. That's pretty neat, seeing what he did just with simple draw circle and draw line algorithms. So very impressive. And this guy DirectX, he is according to his post, he has had no programming experience before getting to my tutorials here. So he's a complete beginner, and he's managed to make a pretty entertaining game here. So I like the art in this game, and I like the fact that he's just a complete beginner. And for the Minesweeper game made by Deloten, it's very good. It uses a lot of more advanced algorithms that we'll be getting into later, things like recursion and stuff. And one thing that I noticed about his stuff here, and let me see if I can, yeah, there we go. Where is it? Let me get this here. Yeah. His code is, it's very nicely written. The formatting and everything, the variable names, it's all very well done. So his coding style is very good. It's something that would not be a bad idea to emulate. Unfortunately, him and also the other guy, DirectX, these guys both are from Germany, so their code has a lot of German in it here. I don't even know how to read that. Kastenhohe. I have no idea. So yeah, but it's very well written code. He's had some experience in coding before, so now very good work, both you guys. I love seeing this shit. So if any of you other guys have something that you're working on, feel free to post it on the forum, and I will check that out. It makes me, I don't know, it gives me a lot of motivation if I see this shit to make more tutorials. And it's just fun. And it's good for everyone else too on the forum. If they can see other people's work, it might motivate them. They can look at the source code and they can get some ideas. So yeah, keep that up. And thank you very much to, let me just write their names on here, to Deloten and DirectX. I think I'm spelling that right. These two guys. They're both from Germany, by the way, so. To show my thanks, I would like to share with you guys a little poem that my grandfather taught me when I was about 4 years old. It goes something like this. Mädchen auf der Fensterbank, putzt die Scheibe blitzeblank. Alle Leute blieben stehen, ihr Scheuerbürstel war zu sehen. I'm sure I murdered the pronunciation on that. I have no idea, but yeah. So that's for you guys. I dedicate that poem to Deloten and DirectX. Now, a couple of matters of business I just want to quickly announce. Let's see here if I can fit this in my recording window. Close enough. So I give a little update on the forum here. Not on the forum, on the blog, on the main page. So if you're interested in, the direction that we'll be heading in the near future, check this out. I also talk about the stuff that Deloten and DirectX did. See, I got their names up there. This is a little bit out of date already because I'm not going to do structures in lesson 14. So structures will be lesson 15 and pointers will be lesson 16. But you get the idea. So check this out if you want to know how things are heading, the road map. And on the forum, I updated the welcome post, and I changed it to read this first, and it has a guide here on how to post your code. So if you need help with something, or if you want to share something, this is how you should post your code. So follow this guide, and it'll make things easier for everyone. So make sure you check that out. And yeah, that's about it. Oh, there's one more thing. Just a short little bragging thing. In lesson 13, when I was pushing the limits of the framework, I found that I could draw 1700 poo on the screen before it slowed down. Well, I tried it out without my recording software on, and I tried it in release configuration, and I got 3000 poo. I could draw 3000 poo on the screen at full frame rate. So with the new enhancements, the framework should definitely be able to to suit our needs, as long as your computer doesn't totally suck. It should be fine. There are further optimizations and faster ways of rendering 2D graphics, but they are considerably more complicated, and so we won't be getting to them anytime soon, but eventually we will. For now, this simple software rendering, direct access to the frame buffer, will suit our needs perfectly. So without further ado, we're going to cut to the part where I start doing actual programming. Let's do that. Alright, I found it. It's right here. Okay, so here's the game. Basically, the face guy, the face dude, he collects these yellow balls. He's liking him some balls. And yeah, he just keeps collecting them. And every time you collect one of the balls, the amount of poo increases. The amount of poo on the screen increases. And that's about it. And that's it. Game over. All right. So that was my challenge to you. If you can make this game or something very similar to this game. So a few things. Just running the game. What we notice is the poo. First of all, the poo is now moving, so we're going to have to update the poo's position every frame. And also, the poo bounces off the walls, so we're going to have to do collision for the walls of the poo, and we're going to have to change its speed when it hits the wall, right? The other thing is that the poos also change direction and speed randomly, so we'll also have to handle that. And when we bump into the poo, it's game over. Beyond that, we have to draw the goal here, the target, and the target has to move randomly. And we have to be able to increase the number of poo on the screen whenever we get the target. So, it's a lot of stuff. Let's see if we can't make it happen. Alright, so stop being slow. I gotta wait for this thing to parse and do all its crazy crap. Okay, good. Now, what do I want to do? Well, I'm gonna take the end poo and I'm gonna turn it down for now. We'll set the end poo to 10. Okay, so we gotta figure out how we're gonna come at this here. Good. All right. Update poo, update face, compose frame, go. There we go. Update face, update poo. Good. All right. So first thing I'm going to do is I'm going to implement I'm going to change the mechanics of the game so that the game is over when you hit the poo. I think that's what I want to do. Alright. So if that is what we're doing, then we're not going to care about all poo is eaten, because we're not eating the poo, right? We're avoiding the poo. So we're going to get rid of all poo is eaten. We don't need that variable anymore. Get rid of that, and let's see here. And get rid of all of this, because it's not important. Oh god. Okay, this tests for collision with all of the poo. So, it stands to reason that this is not important. We don't care if poo is eaten or not. We don't care about that. George Bush doesn't care about black people. Okay, so what this is doing is it's looping through all of our poo, and it checks to see if the poo has collided with the face, or vice versa. And if that has happened, then what we want to do is we want the game to end. So game, that's too big. Game is over is equal to true. So we need a variable here. Bool. Game is over. I almost spelled it like over, but I'm not going to do that. The sushi battle is over. You know what that means? That's from Iron Chef. Good old Iron Chef. Game over. Game is over. False. So obviously we want to start the game off in the game is over state being false. And then sometime it will turn true when we collide with a poo. Hey, that rhymed. Alright, so we don't need this poo is eaten thing here anymore. That is obsolete. And this is obsolete. Because poo is not eaten. Poo is not for eating. Mr. Face has finally learned that poo is not dessert. Okay, so now we have it so that when we collide with the poo, game is over. And yeah. The question is, what do we do when game is over? If game is over, draw game over. Now, in my version of the game over screen was drawn over everything. So I'm going to go X there. There we go. So we'll draw it last so that it gets drawn on top of everything else. Small detail, but... And the other thing is that when the game is over, we stop updating. So, if not game is over, update. I have to be able to see my keyboard. I won't know where the buttons are. I still haven't gotten used to this wonky keyboard. Alright, so... yeah, so when the game is over, we draw the game over screen. And when the game is not over, we update everything. So when the game is over, we stop updating, but we still draw the face and the poo and everything. So you can see the state of the game as it was just before it ended. But you can't, it won't update, so you can't move the face or anything. No more moving, no more nothing. You are dead. Okay, poo is eaten. Where did that come from? Ah, right. So this is only drawing... whoa. Just knocked over my microphone there. This is only drawing the poo if it hasn't been eaten. But of course we don't eat poo. That's insanity. Only coprophages eat poo. And Mr. Face is not a coprophage. Alright, we got a success. Let's start this. Okay, we got our poo, and we're avoiding the poo. Oh, we don't want to touch the poo. Oh, we touched the poo. Game over. Alright. So, we have just implemented part of the functionality, wherein touching the poo is bad news bears. Now, what's the next thing we want to do? I think the next thing we want to do is we want the poo to move. So how do we do that? That's the question. First off, if the poo is moving, it's going to need a speed. We don't want the poos to all move at the same speed. We want them to move at different speeds. So, what I'm going to do here is I'm going to make some arrays for the poo speed. But I'm going to be sneaky about it, okay? I'm going to make them floating point numbers. Float poo x velocity in poo and float poo y velocity in poo. Now you may wonder why I'm making it a floating point number, and the reason is simple. Well, not that simple, but it's fairly simple. I mean, if you make your velocities, if you make them integers, you can only move at integer speeds, so you can only move at 1 pixel per frame or 2 pixels per frame or so on. But if you want to move any slower, then it's going to be more complicated. But if you make your velocity a floating point number, you can move at, you know, half a pixel per frame or even slower than that. So you can move nice and slow. But in order for that to work, you also have to have your x and your y's be floating point numbers. Right, because if you don't do that, let's say your velocity is 0.5. Let's do this. Let's do this on the whiteboard. All right. So you've got int x here. We'll call this x, right? 50. And you've got float velocity x, vx, and that is 0.5 f, right? And so when you update the position of your x value, what you'll do is you'll go, well, x is equal to x plus vx, right? So that's not good. So x is 50, vx is 0.5 float. You add those together, well, first what happens is this gets converted to 50.0 float, and then this gets added to this. We get 50.5 float, and that gets converted back to an integer. And what happens? It goes back to 50. So it doesn't move at all. So that's why you can't have this an integer if your velocity is going to be floating, because it just won't work out very well. So what we do is we put our position variables, our coordinates, as floating point numbers. So now we can be at like, you know, 0.50, 0.5, right? And so it will remember when we've added like small numbers to it. And yeah, I mean, when you draw this on the screen, right? Like, let's say this is the screen, right? And this is 50. So our point is here. And we'll say this is float x, and we've added 0.5 to it. So now we're at 50.5f. When we go to draw this on the screen, we can't draw, like if this is 50 and this is 51, we can't draw a pixel between 50 and 51, right? You can't do that. That's no good. But what happens is, like if we call put pixel with 50.5 floating point, it'll just convert that to an integer and it'll draw it at 50. But the next time we move again, we will add another 0.5 to it and it will become 51.0f, and then the pixel will move. So what that means is that it will take 2 frames to move 1 pixel over, which is what we want, right? If we're moving at 0.5, then we'll take 2 frames to move 1. I hope that makes sense to you guys. I don't know. If we use floating point numbers, it'll make it a lot easier to move slowly or at more precise speeds on the screen. That's all I want to say. If you don't get it, then do it yourself and see how it works. Or ask a question. That's always good too. Questions are fine. Alright, so first thing we do is we make variables for our velocity and our position. We had our positions, but we turn them all into floats. Then what we do is we got to update those. Well, first we want to initialize them. And this is complicated. I'm not sure exactly what kind of speeds I want. I forget what the speeds were in the other one. Let's try poo x velocity. No. At index is equal to, and now we need to have some expression to calculate a range of velocities. Basically, I want the velocity, the x velocity, Vx, to be from negative 4-ish to 4. So negative 4 to 4. Negative 4 will be moving left and 4 will be moving right. But how to calculate that? How we're going to do this is we'll get a random number. Rand mod 4000. So this will give us a number between 0 and 3,999, which is basically 4. I mean, I could put it 4001, but whatever. So this will give us a number between 0 and 4000. Then we divide this by 1000 floating point, which will give us a number between 0 and 4 floating point. And then we subtract 4 floating point. Wait. If I subtract 4, no. Yeah. Subtract 4 floating point. And this one should be 8,000. So this will give us a number between 0 and 8. And if we subtract 4, that'll give us a number between negative 4 and positive 4, right? Because if it's 0, 0 minus 4 is negative 4. And if it's 8, 8 minus 4 is positive 4. So this expression here should give us a number, a random floating point number between negative 4 and positive 4. Alright, I hope that works, because I don't have any confidence in this calculation whatsoever. I literally just pulled that out of my ass. I don't remember what I did for the other one, but I'm sure it'll all work out in the end. Same thing for the y. Our speed will be negative 4 to positive 4. Alright, so here we initialize our velocities. Now, we gotta update this mother trucker. We'll update before we check for the game over case. So, wait a minute. I'm being stupid. I should not do that. I should be checking in here because I'm already looping through all of the poos. I should be updating inside the same loop that I'm checking. That would be the smart way to do it. Alright, so in here, we're going to have to update. This should be easy, right? No, it's not going to be easy because I got to check to see if we're outside of the screen boundary. And if we're outside of the screen, then we got to do a bunch of annoying crap. Okay, pain in the ass, but let's do it. First, let's work on motion. So, face x plus and equal. This just means face x is equal to face x plus, why am I saying face x? Pay attention, derp face, poo x plus and equal poo x velocity at index, bam. And I'm gonna be smart for once, and I am going to copy and paste this mother. Okay, so here we're just adding the velocity to the position here. We're updating the positions with our velocity values. I don't know if I've explained this before, but this is the same as poo x equals poo x plus poo x velocity index. So this is equivalent to this. So yeah, just another operator. It's the same deal, it's just a different way of writing the same shit. Okay, so now we update our position. That was the easy part. The hard part is now we've got to determine if we're outside of the screen. So, how do I do this? If poo x is less than 0, ow, that hurt, then poo x is equal to 0. So that means, let's say we have our, you dirty cocksucker. Let's say we have our screen here. This is our screen. And I'm going to do something sneaky. If I can find my layers. I'm going to make a new layer here. Ooh, I'm a sneaky one. And then we got our, let's say this is our poo. Or at least that's the bounding box of our poo. Alright? And our poo is moving around. Look at him go. And he's moving to the left. And in frame 51, he's here. And in frame 52, he moves here. And now he is poo x here will be negative, I don't know, negative 2 or something. So it's less than 0. So he's outside of the screen boundary. So what we got to do is we got to do two things. What did I do here? I hope that didn't do anything bad. Okay, good. Are we safe? Whew, we're safe. Okay, so what was I saying? Oh yeah. So we're moving to the left, and we go off the side of the screen here. And when that happens, we enter this if statement. So what we want to do is, the first thing we want to do is we want to readjust the position of the poo. So we want to, first of all, move it back to the edge of the screen, because we don't want to have it hanging off the edge here. We don't want our junk hanging out, flapping in the wind. You know, it's not seemly, and it can get you arrested. So we reset our poo to right at the edge of the screen, and then we do something a little sneaky. We say poo x velocity at the current poo is equal to negative poo x velocity at index, which is our current poo. And what that is doing is, so we had a velocity here, and our velocity, we're moving to the left, so our velocity was negative something. We'll say it was negative 2 pixels per frame. And we're moving, we go off the edge. So what it does is it sets us back to the edge, and it sets our velocity to negative whatever it was before. So if our velocity was negative 2, it's going to set our velocity now to 2, which means we're going to start moving in this direction. All right? So we were moving here, we went off the side of the screen, and the program grabbed us by the scruff of the neck, shoved us back to the edge, and flipped our velocity in the opposite direction. And now we're moving this way. So what the player sees is it sees the block going this way, and then boom, it's coming back. Comes this way, and then it bounces back. So that's the kind of thing that we'll get with this. And we'll just do the same thing for all the other sides of the screen. So else if. I'm doing an else if here because you can't hit both the left edge and the right edge in the same frame. It's impossible. So for example, if we go off the left edge, then we will definitely not go off the right edge, so we can just skip this one. If poo x is if poo x plus 24 is greater than, geez, I think it's 799. Yeah, that seems about right. If I'm wrong, it'll become apparent. Damn you. Yeah, you can go suck a big black dick. Poo x is equal to 799 minus 24. Yes. And this is the same. Poo x velocity is just negate it. It's opposites day. And we'll do the same for y. So y, no, y. I could do find and replace, but I just don't feel like it. I'll do Control C. Oh, that's not a control. Control C. What the hell? Control Z. Okay, let's try this again. Poo y velocity. Now, Control C. Control V. Control V. Control V. Control V. Control V. Are any of you screaming at the screen right now? You should be, because I almost did this, which would have been bad. But I didn't do it because I was paying attention, sort of. Okay, so Hopefully I changed all of those x's to y's and did not miss one of them, because if I missed one of them, this is going to fuck up. It's all good. So yeah, if we hit the edge of the screen, we reset just to the edge, and then we go in the opposite direction. And if we do this correctly, everything should be copacetic. Well, I can't see any possible way that this could go wrong. And that probably means we're fucked. Yeah, what? No? What? Okay, this is just, it's all pissed off because I'm converting from floating point to integer or something like that. Integer to floating point, and it doesn't like that. Error. Ah, yes. That would be a problem, wouldn't it? We have to say which element of poo_x and poo_y we want to access. Big problem. Okay, where else did I fuck up? All over the place. Cannot convert from int to float 10. I'm not used to writing these with arrays and stuff. That just wasn't. Okay, I gotcha. I understand what you want me to do, and I am doing it. I'm all about doing this. I'm all about array indexes. Except for this one, which I missed, but I didn't. Okay, so apparently this works. Please don't fuck up. And game over. But it was working. Let's start again. Look at that. Look at all those poos moving around. This is beautiful. This is like a fucking... what do you call those things where they all like swim in the water? Synchronized swimming? Yeah. It's like a choreographed something with ice skating. Yeah. Ice skating. That's kind of gay, but whatever. Yes. So this seems to work good. Well. I meant to say well. Why is this taking so long? This is weird, but my Visual Studio is like freezing up every time I finish running the program, and it's pissing me off. I will not lie. It's kind of pissing me off. Get out of the way. Wah. So we can dodge the poo all day long now. Whoa. And they got like different speeds and stuff. So they're wily. These are some wily poos, let me tell you. So as far as I can see here, we have no problems with how this is working. This is working out quite well. So what feature do we want to implement next? Ah, my leg hurts. God damn it. I need to stand up and take like a walk or something. But I'm not gonna do it. I will soldier on. Next thing we want is I guess we'll implement the goal. The goal is the yellow ball. Wait a second, I'm gonna take a piss. Much better. Alright. Okay, so what was I talking about? I think I was saying that we have to make the goal. The goal is a yellow disc. It's a solid yellow circle, which is like a disc. We will call it a disc. Now the thing about discs is I didn't show you how to make a disc. I showed you how to make a circle. That's the bad news. The good news is that it's easier to make a disc, at least in the way I'm going to show you, and you can use a lot of the same math that you use to make a circle. So it won't be that hard. So let's make a disc. Let's go to graphics, d3d graphics.h, and we're going to add a function in here. Void draw disk. Disk. Yeah. We're going to draw our disk at int cx, int cy. These are the center points. Int r for radius, and then int red, int green, int int blue. No, I just want to be there, blue. Okay, so that's our draw disk function prototype signature thingamajig. Now we go graphics.cpp and we are gonna define that mother trucker. Void draw disk d3d graphics. I didn't forget it this time, did I? No siree. Ouch, I just banged my finger. Finger bang. Okay, so I need to explain how this works for you guys. So when we drew a circle, and it was hard, kind of, but not really. Drawing a disk is easy because I said so. So let's say we want to draw a circle at some point cx, cy. Here's our circle thing. It has a radius of r. This is r. Beautiful. Okay, what you're gonna do is you're gonna imagine a box around that circle. God, this really sucks. This diagram is the worst ever. Okay, you're gonna imagine a box that fits around this circle that is really not a circle at all. It's like a potato, but the circle just fits perfectly in the box. Okay. Now, when you want to draw a solid circle, all you have to do is color all the pixels that are within the distance r from the center. So, for example, I showed you guys before that the distance is equal to square root of x minus cx is 1 point. So distance between 2 points plus y minus cy squared. Okay, so if we've got a point here, and that point is, let me just do this here, xy, and this point is cx, cy. The distance d is equal to the square root of x minus cx squared plus y minus cy squared. Alright? And if d is less than r, then we know that our our point here is within the circle, right? For example, if we had another point xy over here, we know that this d is going to be bigger than this r. This is bigger than this, so therefore this is outside of the circle. We do not color this, right? Same as this point here. This point, this distance here is bigger than this distance, so we don't color this this pixel. So what we do is we loop through all of the pixels, and for every pixel we check the distance from the center of our circle. And if that distance is less than the radius, that means it's inside of our circle or our disk, and so we color it. But it would be stupid to loop through the entire screen, right? All we need to loop through really is just this box that encircles our circle. Yeah. So this box is basically this is cx, cy, this box is, here we have cx minus r and cy plus r. That's stupid, but you get the idea. And here we would have cx plus r and cy minus r, right? So we just loop from here to here, and we check the distance for every pixel in this box here. And if that distance is less than our radius, we color it in. And then we get a disk. And that is how easy it can be for you. Okay, so let's translate that into code. For int x is equal to cx minus r, as long as x is less than cx plus r, x plus plus. And we'll do the same thing except with y. Tabulate that mother trucker. So this is a y. Y. And here we go. Y. That's a y. No, no, why did you do that? That was not called for. That was uncalled for. Okay, so we're looping through our x's and our y's, and it's all good. Now we want to make a big test. If, my friends, am I gonna have to import some? Yeah, I'm gonna have to include some shit here. Include mathematical. Okay. If Squirtle, if Squirtle derp x minus cx times is x minus cx plus y minus cy, y minus cy. This is our squared here, remember. Now here's the thing. There are 3 versions of square root. One takes a long double, one takes a float, and one takes a double. These are all floating point variable types, but they have different precisions. They can hold different amounts of data. So we want the float one, the smallest one. So what we have to do is we have to convert this result here, which will be an integer. We have to convert that to a floating point and then take the square root. Because if we don't convert it to a float, it'll be like, well, what the fuck? Which one do you want? There's like lots and stuff, and I don't know which one to convert it to. So you have to explicitly convert to one of these here. Because if you don't, the world will blow up. I'll show you later what that means. You'll get it. You will get it. Mark my words. So if... Oh, we didn't make a... This is not a complete statement. If the distance, which is all this mother truck, is less than r, how should I do this? Meh, I'll just do it like that. Distance is less than r, then put pixel at x and y and rd and g and b, and if not, then go fuck yourself. And that is how you draw a disk. Booyah. Disk me. Worked on the first try. Always ominous. Now let me show you what happens if we omit this explicit cast to floating point. Ooh. We get a failure here. It says ambiguous call to overloaded function. So it does not know which version of square root to call. Because, like I said, this result is an integer, so it has to convert to another one here, and it doesn't know which one it should convert to unless you tell it explicitly. You gotta be float. And once you convert this to a float, it'll say, okay, that means we're going to be using this version of square root. So that is why you need this. Build solution. And happy days. Now we're going to test this out. So we're going to draw a disk here. We'll just go to our... I forget what I'm doing now. Sometimes I go into a kind of fugue state and I have no idea what I'm doing. I just kind of wander around the code. It's hard to talk and do stuff at the same time. I'm not built for this kind of stuff. Graphics dot draw disk. We're going to draw the sun. We'll draw it at 100, 100. The radius will be 80. And, okay, how do you make yellow? Because I forget. Red and blue make like purple. I think it's like red and green. Maybe? Let's try that. I really have no idea. So we'll draw a big sun on the screen. Debug. Yeah, it works. Damn it. It actually worked on the first try. I can't believe that. Damn, I am good. Did I mention that lately? I don't know if I have, but it's true. I am pretty awesome. Alright, so... yeah, so that's how you make a disk. Just a slight little detour there into a little bit of graphics and mathematics. Now, if you weren't able to make that disk, if you weren't able to think of that algorithm yourself, or find it online, you could have just used like a circle. You could have just copied and pasted our circle drawing algorithm. Just like draw a circle, and yeah, it's good. Good enough for government work, right? So, I mean, don't let small shit like that hold you back. If you're like, I can't make the filled-in circle, I cannot proceed. My life is incomplete. No, don't worry about it. Just make do with what you got. I mean, try, of course, if you can. If you have the time, try to figure out how to make that filled-in circle. But, like, I mean, don't pull your hair out over it. Don't throw your back out. We do not need any hernias over this. But, yeah, so anyways, circle complete. Mission accomplished. And now, again, my Visual C++ Express has frozen up on me. What? Honestly, like, what the fuck, bro? What could you possibly be doing that's taking this long? This does not make any sense, and it pisses me off. It's happened to me before, too. Okay, so now we can draw our disk. So now we have to make our goal. So we need more variables. Int goal x int goal y. All right. So we're going to make some new variables here. How do I want to accomplish this? Reset goal. we're going to make a variable called reset goal. No, that's not a variable, that's a function. Ah, my brain is turning to mush here. It's too late in the evening for me. So far, well past my bedtime. Okay. What the fuck? No. Update. Reset goal. That's what it was. I cannot think anymore. And in this function, we just want to set the position of the goal. So we want something like this. We want goal x is equal to what is it equal to? You see, our poo and our face are drawn. Let me just show you what I'm thinking of right now. Let me give you a little quick peek into the inner workings of Chili's mind. This is Mr. Face, and this is Mr. Poo. We draw our poo and our face based on the top left-hand corner. But we draw our disk based on the center point. So, I mean, when we're positioning our poo, we want to position it anywhere from 0 to 800 minus the width of our poo, which is 24, or 799 minus 24. But if we want to position our circle disk thingy, we can't start at 0, right? Because if we put our circle at 0, it's going to be half off the screen. It's like half-assed right there. It's not good. So we want to position it from, basically from R to 799 minus R, right? Here. So my friends, that makes things more difficult, basically. How will we do it? Well, we do random rand and the radius of our circle-y thing will be, I haven't decided yet what the radius will be. We're going to be smart and we're going to use a define. I should use defines for other kinds of things, but our goal radius is, I don't know, 8, 10, 15? 20 pixels-ish? No. Nah, it's going to be 10. The radius of our goal is 10 pixels. So 800. Something tells me that should be 799. It's in times like these where I kind of I vacillate between 800 and 799. Times goal minus goal radius times 2. Yes. Plus goal radius. Does that make sense to you guys? Basically, 799 minus goal radius times 2. So whatever. Okay, so 799. So if we did, let's say we did rand and mod 799, that would give us a random number from here to here, right? And if we drew our circles there, we'd get one from here to here, and that's no good. What if we did rand blah and 799 minus 2 times radius? Well, that would give us from 0 here, and 2 times radius would be 1 times radius, 2 times radius. So we'd get a circle here. So we get one from here to here. And you say, well, this one's off the screen, and that's no good. And this one can't even make it to the end of the screen. The farthest it can make it to is here, and that's no good. But then we go rand mod 799 minus 2 times radius, and then there should be a D here, and then we add radius onto the end. And what that will do is that will give us one from here to here, but then we add 1 radius, so we get from here to 1 radius here, which is exactly what we want, from this edge here to this edge here. And that is why we subtract 2 times the radius here to give us our random range, and then we add a radius to the end because we don't want it to be at 0 and have its ass hanging off the side of the screen. Ooh. Okay, that's my explanation, and it's gonna have to do. So this is how we randomize our position. Don't you love calculating random variables and all the different ranges and stuff? Isn't it just the most fun thing in the world? Okay. So now we do a little bit of copy-paste style, and we're all set. So this is the reset goal function. Builder. And it worked. So we're going to run reset goal in here. And we also want to do one more thing here. We want to draw our face. Here we're going to draw the goal, which is just basically gfx dot draw disk at goal x, goal y, radius is goal rad, color is, we're just hard coding this one, 255, 0. So now we draw our disk at a random position. My fucking program's gonna freeze up now every goddamn time. Oh, I hate you. Oh, why did you do that to me? Goal, because I did this. Capitalization not correct. So we got our goal thing at a random sort of position. Oh good, it didn't freeze up. Excellent. Let's try it again. Now it's over here. Good times. And let's try it one more time. It's over here. Game over right when you start. What? That's a real dick move for a game. Game on. Game over. Yeah. Alright, so apparently our thing looks rather random. To me, it seems sufficiently random for my needs here. So, now my thing froze up again. Okay, it's good. Good. Now we have to do the code for when we actually run over the goal. And we'll do that in the same place where we update the face. So when we update the face, we'll, update the position of the face. We'll clamp the face to the window. And then we'll check to see if we have hit the goal. So, now, with the other ones, what we did was we did bounding box collision testing, right? So this is our poo, and this is our bro, and if their bounding boxes overlapped, then they were assumed to have collided. It's not perfect, especially if you have, for example, if you've got two round things, right? And you got one here. Their bounding boxes could overlap, but the actual graphics themselves are not overlapping. So, I propose another solution. Now, since our face and our goal are both circles, we can use circle collision, which basically states that if the distance between their center points is less than the sum of the radiuses r1 and r2, so if r1 plus r2 is greater than the distance between, c1 and c2, distance c1, c2 is less than r1 plus r2, then that means that they must be overlapping each other, right? I mean, if you've got two circles here and they're like this, obviously this distance is less than r1 plus r2, because r1 plus r2 would be like this long, and this distance is this long, and this is shorter than this, right? So they are obviously overlapping. So what you want to do is you want to find the distance between two centers and then check to see if that's less than the sum of their radiuses, or radii. So, what we do, I'm going to copy and paste here because I'm lazy. This one. This one? This one. Alright, so if this expression is less than, what's the radius of our face? Our face is 20 pixels wide by 20 pixels tall, so the radius is about 10. So if the radius is less than 10 plus goal radius, boo, then reset goal. So if we hit our goal, we want to reset it to a different position. Alright, now we got to change these variables. So x is obviously face x. And y is face y. Cx is our goal x. And cy is our goal y. This is getting long. I am gonna do that. Okay. And if that stuff square rooted is less than the sum of the radiuses of our face and our goal, then we reset the goal. Failure! You fail! Square root identifier not found. That's an easy one. That just means we need the maths. Math.h. My throat is getting sore from talking. I'm getting tired too. Ah, you cocksucker. And now my thing is frozen up again. My thing is frozen. Finally. Oh, God. I gotta figure out what the hell is the matter with this. Whatever. It works now. Build. Yeah, that worked. Okay, let's try this again, and hopefully we won't die before we can get the thing. Oh! I could just reduce the number of poo, but I'm not gonna do that. Oh! This is kind of yeah, let me know. Okay, come on, just let me do it, bro. Just let me do it. I want to do it. I want to be the guy. All right, here we go. I can do this. That didn't work. It sort of worked, but then it didn't, and then it did. There's something wrong here. There's definitely... Ah, I know what it is. I know what it is now. Alright, so I'm measuring from... I'm taking the distance from face X to goal X, right? But... let me just show you. Our face sprite here, face X is actually the top corner. And whereas, you know, goal X is the center. So what I want to be doing is taking the distance from here to here. But I'm not doing that because I'm a derp. So what I need to do... Oh, and my fucking thing. Ah, finally. Okay. Yeah, so what we want to do is we want to calculate from here to here. So first we have to translate this point to here. So, yeah. So we're going to say int cx, which means the center of the x of our face, is equal to face x minus 10. No, wait, plus 10. Plus 10, plus 10. And int cy is equal to face y plus 10. And then we're going to go copy, paste, copy, paste. No, paste. There. Okay. Now this should sort of work, kind of work. No! Nah, I couldn't get to my direction key fast enough. Ah, you cocksucker. Okay. Oh, I totally could have avoided that one. Oh, get away. Okay, I got it. Yep. There we go. Okay. And this one? Yep. So, now we are able to get our goal. And every time we reach the goal is reset to a different position. Then we can go there and get the goal. Here it is. Now it's over there. Now it's over here. Hello, Mr. Guy. You are my guy. Alright. So that's good. In the next feature that we're going to do is whenever you get the goal, it increases the number of poo. I'm going to show you how I did that. So we'll set our n poo at 10 here. But here's where the trick is. Our n poo variable, remember, these are two different things. This is the n poo define constant. But we also have an n poo variable that is part of our game object. And that n poo variable it controls, where's the update poo thing? Here it is. It controls this loop here, which determines up until which poo index we are calculating. So, I'm going to do something. First of all, I'm going to change this one to npoo. I'm going to change this one to the npoo constant. And I'm going to change our npoo variable. Instead of making it the value of the constant, I'm going to make it 1. Now, what does this do? Can you predict what it's going to do? Don't pause the video. Predict what you think this change will do here. So now we only have one poo running around the screen. That makes sense. Why does it make sense? Well, even though we have the npoo constant is 10, so we have 10 poo objects here. But even though we have 10 poo objects and we initialize 10 poo objects, we're only updating the first one because the npoo variable is equal to 1. So we're only updating the first one, and down here we're only drawing the first one because, again, npoo is only equal to 1. So this npoo variable determines how many of our poos we are going to draw. Do you understand now? So all we do then is we start off with the npoo variable equal to 1. And every time, where is it? Where are you, you dick face? Here we go. Every time we reset the goal, the last thing we're going to do is we're going to go npoo plus and equal, no, plus and equal, my friend, plus and equal 1. I could do npoo plus plus, but whatever. So we're going to, every time we hit a goal, we're going to increase the number of poo by 1. Oh, I did something strange here. Now I have 2 poo when I start off. Now there's 3 poo, 4 poo, 5 poo, 6 poo. Whoa! 7 poo, 8 poo, 9 poo. Whoa! I wanted to do something there, but I didn't because I was stupid. Yeah, so we start off with 2 poo because npoo is equal to 1, and then we call reset goal, which adds another 1, so we get 2. So if we want to start off with only 1 poo, we should start off with npoo equal to 0. We could also start off with npoo equal to -1, and that would let us start with 0 poo. But we'll start off with this. I got my goal. 3 poo. Whoa, these ones are fast. 4 poo. Here's a nice slow one for me. We'll just wait out the poo. 5, 6 poo, or 7, 6. Whoa, jeez! Whoa! Whoa, bro! This is 8 poo. Whoa! That was close. That was really close. 9 poo. I think this is 9. 10 poo. So what happens if I go for 11 poo? Wow, something weird's happening. Is that actually 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't even know how that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's 12 poo on the screen. So you may be wondering, what is the chili going on about here? Well, let me show you. I counted 12. That's right, 12 poos on the screen. But our npoo constant here is defined as 10. And so that means that there is only 10 elements in each of these arrays. So what happens when you access the 11th element or the 12th element of a 10 element array? Well, Let me show you here. Let's say we got our memory here. We got poo x and poo y. These are all arrays. Poo x velocity. I'm not gonna write out velocity. Who do you think I am? I'm chilly. I'm a lazy bastard. And they've got like, 10 elements in each. Let's pretend this is 10. So there's 10 little memory locations assigned to each of these arrays. And up here we've got other variables, and down here we've got other memory, which could have variables or whatever. We don't know. But here are our 4 arrays. So for example, if we're accessing if we're accessing the first poo object, we would be accessing index 0. And so we would access here, 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 and here, right? That's if we were accessing the first poo object. Likewise, if we were accessing the last one, index 9, we would be accessing here, 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 and here. So what happens if we access the 12th object? That would be index 11. Well, then we'd be going, here's the index 9, 10, 11. So we'd be accessing somewhere around here. So when we tried to access poo 11, we'd actually be accessing poo y at 1. And the same goes for here, here, and here, right? So we'd be accessing things that meant something completely different. We'd be accessing the x, we'd think this was the x, we were actually getting at the y of some other object, right? And the most alarming is when we're accessing down here, because we don't even know what the hell is down here. It could be unused memory, in which case we would just use it for our own purposes, but it would be uninitialized, so we don't know, we have no idea what's sitting in there for the velocity, right? But it could also be some other variables from our program, and when we change these variables, like for example when we change the velocity, that could just screw up something else in the program. Or it could be variable, it could be memory that's being used by another program. So there's a whole slew of shit that can go wrong. But as you noticed in the previous or just in, I guess, about 3 minutes ago, when I ran the program, it didn't it didn't do too bad, actually. I mean, if you were paying attention, you could see that there were definitely some artifacts there, but it didn't explode or anything. So, and that is the danger, my friends. You can have problems where you're accessing memory that you shouldn't, and the program still doesn't do anything incredibly crazy, and you could even, completely overlook it. You could not realize that it's happening. So that's a problem, and there are a few steps that you can take to avoid that. Now, the first thing is that when I ran it, I built it in the release configuration. So I was running it under release. So let's make a change here. We're going to initialize our npoo to 11 here. And that means that it will be 12 when we start, because it will also call reset goal, which will increment npoo. So we'll have 12 poo again in a 10 poo limit. This time we're going to run it under debug. And we'll see if that changes anything here. I'm going to build it. Alright, success. And I'll get my hand on the direction pad just to make sure I can dodge if I have the opportunity. Alright, so again, we're getting kind of wonky shit going on. The poos are flickering and they're acting all weird. So yeah, definitely definitely getting fucked up here. Let's close the program, and we get a little warning here. Runtime check failure number 2. Stack around the variable WR was corrupted. So stack just means memory. So the memory around this WR variable, which is part of the framework that we haven't talked about yet, was corrupted, meaning it was accessed when it shouldn't have been, and it got all fucked up. Now the reason why we get this this little message is because when you build your program under debug configuration, it inserts a bunch of code to check for problems, and that code can slow down your program, but it can also alert you of a bunch of shit that you might have not noticed otherwise. So that is, we don't just use debug because we can step through the program. We also use it because it inserts a bunch of error checking code in the background. So there's another reason why you would like to you'd be using the debug configuration when you are in development. All right. So let's fix NPU. We'll set it back to 1. Or 0, I should say. And yeah, so let's make sure that that bad stuff cannot happen. So what we should do here is, because we're changing the boundary of what we can access in an array, we should always be checking here to make sure that we are not exceeding the size of that array. So if NPU is greater than NPU, I should have named those with better names. That's rather confusing when you say it out loud. Then NPU is equal to NPU, right? So if at any time we have exceeded the number of, or the size of our array, then we should just set NPU to be equal to the size. And that will cap our number of poo to be looped through. That will cap that number to be the size of the array. And I'll just set that to 5 just to demonstrate here. Oh, I gotta run it. Whoa, get away! Woo! So we got 2 poo now, 3 poo, 4 poo. That was close. 5 poo. Get away from me. And still 5 poo. So now we have safely capped the number of poo at 5. It's a rather low number, but whatever. We'll set it to 25. Okay. So that is that little mystery solved. And I mean, yeah, it ran fine on my machine, but on another person's machine it might actually crash. So you can't rely on stuff like that. You have to make sure that your memory access is tight. It's one difference between programming in C or C++ and programming in a language like Java. C gives you a lot more power, but there also with that power comes a responsibility. Now, what is the last? I mean, what else do we have to implement here? I think we're pretty much almost finished with all the features. Ah, okay, I see. We also have to implement random movement of the poos. Every now and then, if you've noticed, in my finished program here, they switch velocity. So we're gonna have to implement that, and it shouldn't be too difficult. I know, because I've already done it. So we'll go to update poo. And we're going to create a new local variable here. We'll call it lottery. It's kind of a stupid variable name, but whatever. And we'll get a random number between 0 and, oh, let's say 200. And here, inside of our loop here, we're going to check to see if the index, the current poo object being worked on, is equal to our lottery number. And if it is, then you are a winner. And that means that you get to have your shit rearranged. So, we'll do a little copy-paste kung fu here. We'll just reuse this in here. That was kind of strange. Tabulate that. Delete that. And there we go. So what this is basically saying is we get a random number every frame, every time we update poo, and whatever poo object whose index matches that number, that object gets its velocity randomized, right? So that means that at most you're going to get one poo changing its velocity per frame. But it could be less because, I mean, there's only 25 poos, but I'm getting a number between 0 and 199. So, I mean, if the number is, say, 100, it's not going to match any of the poos, and so no poo will have its velocity changed in that frame. So by setting this to a larger number, you can reduce the rate at which the poos change their velocity. But you can never increase the rate that you change their velocity to more than one poo per frame. So if you want to, you know, have more than one poo changing its velocity per frame, then you're going to have to use a different method. But I mean, that's not really a good idea, because if you want like lots of poo changing their velocity per frame, it's going to look like somebody, like they got Parkinson's disease or something. I don't know. They'd be like jittering all around the screen. I hope I offended a whole bunch of people with that statement right there. I regret nothing. Okay, so yeah, that is that feature in the bag. And I think that's it. That is all she wrote. We have... Whoa! He just sped up. Whoa! Calm down there, buddy. Just calm down. So this is the game, pretty much. Close enough. Get away from me, you dick faces. Get away! So, yep. That's about the end of this lesson. Ended up taking a long time, so I wasn't able to teach any new topics. I mean, any new programming constructions or what have you. But it was a good experience. Just as a little recap, some things that we learned here that were good. We learned that using float for your position and your velocity is good, because it allows you to have much more fine-grained control over the speed at which things move. So even though your output, your actually graphic screen works in integers, right? You can't, you know, have half a pixel or something. Even though that works in integers, and there's nothing stopping you from making the representation of your world in floating point values. This kind of gets back to what I was talking about a little bit before, about model and view, right? So I mean, in your view system, you've got a screen and it has discrete pixels, right, integer. But in your model, you've got your positions and they're like floating point values, right? You got a bunch of floats here and they're all floating about. So In your model, things are kind of continuous. A floating point is close enough to continuous, right? And in view, they're very discrete. And so when you go to render, you're converting from float here to integer. And that happens a lot. I mean, in 3D graphics, everything is represented by triangles, and those triangles are represented by points in space. And all those points are going to be floating point values, right? And you imagine a triangle as being lines connecting those points, and those lines are ideal lines. They're perfect lines. And when you go to render them, then you're converting them into discrete pixels. So, just something to think of. If that made no sense, don't worry about it. I'm not sure it even made sense to me. Other things that we learned how to draw a solid circle, a filled-in circle, or a disk, if you will. Quite simple. Simpler than drawing a hollow circle. We just made use again of the distance formula, or the Pythagorean theorem, which we used to draw the circle, and loops, and it was good. I would not recommend using this in a performance-based program to draw a lot of disks, because this is not the most efficient way of drawing them. But it is one of the easier ways to understand, so that's why I went with it. And we're only drawing one of them on the screen, so it's not going to make a big difference. You can optimize the hell out of this algorithm, and it will not speed up your program worth shit. So, drawing disks. And one other thing that we did here, if I can find it, update face. Here it is. We did a collision test here, but instead of using our good old friend the bounding box, we used circular collision detection, which is by comparing the distance between the centers of two objects with the sum of the radii of those objects, right? Again, distance formula, which is just Pythagorean theorem in disguise. Man, that Pythagoras, he sure got around. He really did it for us. Hats off to that guy. And yeah, so circular collision detection is good, especially if the objects that you're doing collision detection on are roughly circular. Then it's much more accurate than bounding boxes. And that is all she wrote about that. So, next lesson is going to be coming soon, I think, because it shouldn't take that long. Unlike most of the other ones, this next one should be short. And that means that I can get it done quicker. And in the next one, we will be learning about structures. So we'll learn some new stuff. It'll be quick, it'll be easy, and then we will move on from there. So until then, you guys have a good one, and don't do anything that the chili wouldn't do, because that'd be stupid.